The Late Triassic is the third and final of three epochs of the Triassic period in the geologic time scale. The Triassic-Jurassic extinction event began during this epoch and is one of the 5 major mass extinction events of the Earth. The corresponding series is known as the Upper Triassic. In Europe, the epoch was called the Keuper, after a German lithostratigraphic group that has a roughly corresponding age. The Late Triassic spans the time between 237 Ma and 201.3 plus or minus 0.2 Ma. The Late Triassic is divided into the Carnian, Norian and Rhaetian ages. Many of the first dinosaurs evolved during the Late Triassic, including Plateosaurus, Carlophysis, and Eoraptor. The extinction event that began during the Late Triassic resulted in the disappearance of about 76% of all terrestrial and marine life species, as well as almost 20% of taxonomic families. Although the Late Triassic epoch did not prove to be as destructive as the preceding Permian period, which took place approximately 50 million years earlier and destroyed about 70% of land species, 57% of insect families as well as 95% of marine life. It resulted in great decrease in population sizes of many living organism populations. Specifically, the Late Triassic had negative effects on the conodonts and ammonoid groups. These groups once served as vital index fossils, which made it possible to identify feasible lifespan to multiple strata of the Triassic strata. These groups were severely affected during the epoch, and became extinct soon after. Despite the large populations that withered away with the coming of the Late Triassic, many families, such as the pterosaurs, crocodiles, mammals and fish were very minimally affected. However, such families as the bivalves, gastropods, marine reptiles and brachiopods were greatly affected, and many species became extinct during this time. Causes of the extinction. Most of the evidence suggests the increase of volcanic activity was the main cause of the extinction. As a result of the rifting of the supercontinent Pangaea, there was an increase in widespread volcanic activity which released large amounts of carbon dioxide. At the end of the Triassic period, massive eruptions occurred along the rift zone, known as the Central Atlantic Magmatic Province, for about 500,000 years. These intense eruptions were classified as flood basalt eruptions, which are a type of large-scale volcanic activity that releases a huge volume of lava in addition to sulfur dioxide and carbon dioxide. The sudden increase in carbon dioxide levels is believed to have enhanced the greenhouse effect, which acidified the oceans and raised average air temperature. As a result of the change in biological conditions in the oceans, 22% of marine families became extinct. In addition, 53% of marine genera and about 76 to 86% of all species became extinct, which vacated ecological niches, thus enabling dinosaurs to become the dominant presence in the Jurassic period. While the majority of the scientists agree that volcanic activity was the main cause of the extinction, other theories suggest the extinction was triggered by the impact of an asteroid, climate change, or rising sea levels. Carnian Age. The Carnian Age is the first stage of the 3 to occur during the duration of the mass extinction era. The Carnian Age developed about 228 to 217 million years ago, and signals the start of the Late Triassic epoch. The Carnian stage can further be broken down to relative species activity during the time, based on fossils and evidence found dating back to this time period. For example, marine life such as Serenites, Nanseni and Trichoceres obusum can be dated back to the early Carnian stage. Meanwhile, Tropids stellari, Tropids wellari and Clomathoids macrolobatus can all be dated back to the late Carnian stage. During the Carnian era, archosaurs took on a powerful role in existence and domination in terms of land and resources. The archosaur species included animals similar to today's crocodile and general large lizards. Many families of prehistoric animals existed during this time period, such as the phytosaurs, ornithosuchids, prestosuchids, rauisuchids and poposaur. Archosaurs populated many areas of the Earth, and were scattered among areas such as today's India, North America, South America, Africa and Britain. Evidence of fossils of such prehistoric animals have been found in these parts of the world. However, during the Carnian time period, separation of the northern areas began to occur, which separated the Laurasian supercontinent existing at the time. In addition, the Gondwanaland supercontinent of the south also began to separate and disperse itself. However, Pangaea was still intact at this time. During these land mass separations, regions were extremely tectonically active, which caused cataclysmic flows of lava, which would eventually lead to rift lines and land separation. Inevitably, this signified the start to the eventual late Triassic mass extinction. Norian Age. The Norian Age is the second stage of the three to occur during the duration of the Triassic mass extinction. This stage developed about 217 to 204 million years ago. This stage comes after the Carnian stage, and is known for its rising populations of Mesozoic organisms as well as the decline in populations of previous species that had once played important roles in the environment. This stage identifies with its own species of ammonoid index fossils, which is how it differs from the preceding Carnian stage. In this stage, fossils and evidence of ceratophlorite spicronators are found in these different areas of the world, which seem to be more complex and advanced than those in the preceding stage of the era. Many species alive during the Norian Age that eventually became extinct lived either in the Tethys Panthalasan Reef Province, or the West Pangaean Reef Province. In the Tethys Panthalasan province, species saw considerable amounts of populations becoming extinct here. Species such as the sphinctizoid as well as other species began dying out, and by the end of the Norian stage, about 90% of these species evolved and remained in the area. Further evidence shows that scientists discovered major rises in sea level towards later years of the stage in which new taxa came into play. Recent Age. The Recent Age is the final stage of the Triassic era's mass extinction. A Recent Age succeeds the Norian stage, and is the step before the eventual Cretaceous era mass extinction. This stage of the Triassic is known for its extinction of marine reptiles, such as nothosaurs and schastosaurs with the ichthyosaurs, similar to today's dolphin. This stage was concluded with the disappearance of many species that removed types of plankton from the face of the Earth, as well as some organisms known for reef building, and the pelagic conodonts. In addition to these species that became extinct, the straight-shelled nautiloids, plecodonts, bivalves and many types of reptiles did not survive through this stage. Climate and environment during the Triassic period. During the beginning of the Triassic era, the Earth consisted of a giant land mass known as Pangaea, which covered about a quarter of Earth's surface. Towards the end of the era, continental drift occurred which separated Pangaea. At this time, polar ice was not present because of the large differences between the equator and the poles. A single, large land mass similar to Pangaea would be expected to have extreme seasons. However, evidence offers contradictions. Evidence suggests that there is arid climate as well as proof of strong precipitation. The planet's atmosphere and temperature components were mainly warm and dry, with other seasonal changes in certain ranges. The Middle Triassic was known to have consistent intervals of high levels of humidity. The circulation and movement of these humidity patterns geographically are not known. However, the major Carnian pluvial event stands as one focus point of many studies. Different hypotheses of the event's occurrence include eruptions, monsoonal effects, and changes caused by plate tectonics. Continental deposits also support certain ideas relative to the Triassic period. Sediments that include red beds, which are sandstones and shales of color, may suggest seasonal precipitation. Rocks also included dinosaur tracks, mud cracks, and fossils of crustaceans and fish, which provide climate evidence. Since animals and plants can only live during periods of which they can survive through Triassic-Jurassic extinction event, species that became extinct in Africa: Alawalia Zendosaurus, Glyconosaurus Euparkeria, Oscillosaurus in Asia, Progonoschles in Europe, Agrosaurus Cameloshodolocosacus, Gerothorax, Haltocosaurus Liliensternus in India, Alwalcaria in North America, Arctosaurus in South America, Eoraptor Pisanosaurus, Storicasaurus. Evidence of environmental disruption and climate change. The Late Triassic is described as semi-arid. Semi-arid is characterized by light rainfall, having up to 10 to 20 inches of precipitation a year. The period had a fluctuating, warm climate in which it was occasionally marked by instances of powerful heat. Different basins in certain areas of Europe provided evidence of the emergence of the Middle Carnian pluvial event. For example, the Western Tethys German basin was defined by the theory of the Middle Carnian wet climate phase. This event stands as the most distinctive climate change within the Triassic period. Propositions for its cause include different behaviors of atmospheric or oceanic circulation forced by plate tectonics may have participated in modifying the carbon cycle and other scientific factors. Heavy rains due to shifting of the Earth, sparked by eruptions, typically originating from an accumulation of igneous rocks, which could have included liquid rock or volcanic rock formations. Theories and concepts are supported universally, due to extensive aerial proof of Carnian siliciclastic sediments, the physical positions as well as comparisons of that location to surrounding sediments and layers stood as basis for recording data. Multiple resourced and recurring patterns in results of evaluations allowed for the satisfactory clarification of facts and common conceptions on the Late Triassic. Conclusions summarized that the correlation of these sediments led to the modified version of the new map of Central Eastern Pangaea, as well as that the sediments' relation to the Carnian pluvial event is greater than expected. High interest concerning the Triassic period has fueled the need to uncover more information about the time period's climate. The Late Triassic period is classified as a phase entirely flooded with phases of monsoonal events. A monsoon affects large regions and brings heavy rains along with powerful winds. Field studies confirm the impact and occurrence of strong monsoonal circulation during this time frame. However, hesitations concerning climatic variability remains. Upgrading knowledge on the climate of a period is a difficult task to assess. Understanding of and assumptions of temporal and spatial patterns of the Triassic period's climate variability still need revision. Diverse proxies hindered the flow of paleontological evidence. Studies in certain zones are missing and could be benefited by collaborating the already existing but uncompared records of Triassic paleoclimate. A specific physical piece of evidence was found. A fire scar on the trunk of a tree, found in southeast Utah, dates back to the Late Triassic. The feature was evaluated and paved the path to the conclusion of one fire's history. It was categorized through comparison of other modern tree scars. The scar stood as evidence of Late Triassic wildfire, an old climatic event. Biological impact. The impacts that the late Triassic era had on surround environments and organisms were wildfire destruction of habitats and prevention of photosynthesis. Climatic cooling also occurred due to the soot in the atmosphere. Studies also show that 103 families of marine invertebrates became extinct at the end of the Triassic, yet another 175 lived on into the Jurassic. Marine and extant species were hit fairly hard by extinctions during this period. Almost 20% of 300 extant families became extinct, and bivalves, cephalopods, and brachiopods suffered greatly. 92% of bivalves were wiped out episodically throughout the Triassic. The end of the Triassic also brought about the decline of corals and reef builders during what is called a reef gap. The changes in sea levels brought this decline upon corals, particularly the calcosponges and scleractinian corals. However, some corals would make a resurgence during the Jurassic period. 17 brachiopod species were also wiped out by the end of the Triassic. Furthermore, conulariids became entirely extinct. Additional reading: Geophone Database, Late Triassic.